yesterday's earlier class, day before yesterday. Can you tell what is the frequency range of discrete signal? Anybody please respond. What is the frequency range of discrete signal? Avik? Avik is there?
Yes, sir.
What is the frequency range of discrete signal?
I don't remember now.
Very good answer. Ankesh?
Yes, sir.
What is the frequency range of discrete signal?
0 to pi.
0 to pi. और थोड़ा increase करो. Negative. What is the negative frequency range?
Minus pi to pi or something.
Yes. So total frequency range for digital signal is minus pi to pi. Or any other range? Kishan? Kishan Agarwal? Neil
Yes.
Paritosh? What is the other range of frequency? What is the other range of frequency? Pranish? You should answer yes spontaneously. Why I need to call your name? Whenever I ask any questions or I put any things for discussion, then that will help for all of you. Okay? Because you'll get the concept from the discussion, from listening to the discussions. So the question should be raised in common to all of you, so that whatever the answers will be there, 0 to 1 or minus half to plus half. Okay, this is the frequency range. You have not studied discrete frequency range. And why this is so? Because cos function repeats after 2 pi radians. And you know that any signals can be dissolved into cosine functions according to the Fourier theory. So cos function is very good examples to explain the property of any signals. Because any signals can be expressed in terms of cosine waves, sum of cosine waves, according to the Fourier theory. Okay. So cos omega 0 plus 2 pi n is equal to cos omega 0 n. So after 2 pi it repeats. So that means all the frequencies after 2 pi the signals are identical, but within 2 pi, 0 to 2 pi, the signals are distinct. And that is the main concept. Okay. Now from that we get the frequency range minus pi distinct to pi, or and that is the main concept. In terms of normal frequency, it is now minus half to half. Okay. And from there, we have studied that if you sample the analog signal, okay, that your original sampling, original signal, analog signal frequency is f, okay, and if you sample with fs, then it is f by fs. So this is your signal frequency f after sampling. Okay. Now, what should be the sampling criteria? You know that frequency range is minus half to plus half, as we have just discussed. Okay, for discrete frequency range or sampled frequency or sample signal, frequency discrete signal is what? It is nothing but the sample signal. So its frequency is minus half to plus half, and it comes from minus pi to plus pi. If you, in place of omega, if we put 2 pi f, then pi will cancel out. It is minus half to plus half. Now, and you can interrupt in between if you have any doubt. I will be happy to hear questions from you. Now, in place of f, we write f by fs. Simply write f by fs. F is the analog signal frequency. Fs is the sampling frequency. So from there, you get fs by 2, and it is fs by minus fs by 2 to plus fs by 2. So it becomes f greater than equal to, okay, here sampling frequency fs is greater than equal to twice f. So this is the relation you already know. Okay, this is called sampling theorem, that sampling it should be sampled at least equal to the twice of the maximum frequency content or bandwidth of the signal, and and if it is same, it may be more than that. Fs is greater than 2f, is or better sampling. Okay, but the limiting condition, that is fs equal to twice f max, twice of f max, is actually the Nyquist rate. It is called Nyquist rate. But the theorem is fs greater than twice b or twice f, twice f max. Is actually the Nyquist rate. F max. This is the sampling theorem, and some Nyquist rate is one specific value, particular value. It is not a range. That is, at least it should be equal to the twice. Sampling frequency should be at least equal to the twice of the maximum frequency. Okay, these things are already known to you. Now we go for the. Is my slide visible?
Yes, sir.
Okay. So representation of discrete time signals. Okay. You know that we can represent discrete time signal as graphically, tabular, or using some functions. So graphically, you can see that for different values of n is equal to 0, 1, 2, 3, 4, or in the negative side, they can take any values. So you can represent that signal in this way graphically, or using some function, you can represent that for particular time instant, n is equal to 1 and 3, it has value 1, n is equal to 2, it has value 4, or 0 otherwise. Similarly, tabular method we can use, that at n time axis you give 0, 1, 2, 3, 4, and also in the negative side minus 1, 2. So their value you can mention like this. Okay. You can easily understand. Now, also you can represent in terms of sequence. Okay. So infinite sequence means that can exist from infinite number of samples, both in negative and positive sides of n. So by mentioning the values in and commas in between, and putting the origin, okay, time origin with some arrow, okay, that represents n is equal to 0. Okay. Now Also, for some cases, if that such signal does not exist for negative values of n, so we need not mention those values, and straight away we can start from the first value that represents the origin value at the origin. Okay, the value at the origin for this case it is 0. Then finite duration, and lastly if it is dot 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 dot, that means it is an infinite sequence. Okay, and if it is a finite length of sequence, finite time duration, so within bracket and some finite values here, 1 2 3 4 5 6 7, it is a seven sequences of 7. Okay, and length is 7, and origin is at the value -2. Okay, that n is equal to 0. Actually, at n is equal to 0, this value exists. Okay, so there are different cases. Okay, so now we elementary signals, we see that discrete time signals. Okay, delta n is equal to 1 for only at n is equal to 0. Here is the difference of the impulse function with original time, continuous time domain. Actually, in continuous time domain, this represented by what? Impulse function is represented by what in continuous time domain? Anybody can tell?
Sir, delta of t.
Delta t. And what is the magnitude?
Magnitude is infinite and area is 1.
Yes, correct. So we get this is the infinite impulse function, but in the discrete case it is only equal to 1. And unit step function, you see that it exists only at n is greater than equal to 0, and it is 1. Okay, unit step function. And unit ramp function, it is urn. So it is for n greater than equal to 0, it is n is increasing, and n less than 0, all are 0. It is ramp sequence. Now coming to the exponential sequence. The exponential sequence, each time the value of signal is changing. Okay, either it may be increasing or decreasing, or they may oscillate. Okay, they sometimes become positive, sometimes become negative. So let us take if the magnitude, so exponential signal is given by a to the power n. So if a is less than 1, that is a fraction. So whenever n increases, if n increases, then it is its value is decreasing. Okay, its value is decreasing. And if say a is greater than 1, okay, each time its magnitude is increasing, because let us say a is equal to 2. So at one instance, say n is equal to 0, it is 2. Then at n is equal to 1, it is 2 to the power. At n is equal to 0, it is 2 to the power 0, that means 1. At n is equal to 1, it is 2. Okay, and at n is equal to 2, it is 2 to the, please mute yourself. Who is unmuted? Naman, your microphone is on. Please mute. Yes. So if a is greater, so next each time the value of the magnitude of signal is increasing. Okay, then uh, say but here if for negative values of n also, in that case when n is negative, a to the power n is negative, So value of n power will be what? A to the power, say a to the power n. So when n is -1, at that time his value will be 1 by a. Okay, and n is -2. Okay, that's negative value of n. The value would be 1 by a square. A to the power -2, 1 by a square, and 1 by a cube, like that. So if a is a fraction, okay, if a is fractions, so 1 by some 0.5, say 0.5, so it is 2, okay, or that certain value. Then if n is equal to -3, okay, if n is equal to -2, then 0.5, 1 by so 0.5 to the power -2. So it is 1 by 0.5 whole square. Okay, 1 by 0.5 whole square. So it is 1 by 0.25. So denominator the value is decreasing in denominator. So the value will increase overall, since it is decreasing in numerator, so the value overall it will increase. So it is a decaying signal for the first case, and for very high value of n, it is it has highest value, okay, when a is less than 1. Similarly, a is greater than 1, okay, it is a decaying function. So depending on the value of this a, so now another case is -a to 0, okay, -a to 0. Okay, so you can see that it is fraction but it is negative. So for positive value, odd values of n, it is negative, these are negatives, and for even values of n, it is positive, but it is decaying function. And for most negative value of n, it has highest value in that side, okay, and increasing value is for a greater than -1, a less than -1. So each time whenever the values of n is odd or even, it is oscillating, okay, positive, negative. So this way you can see that it behaves oscillating for exponential signal if it is negative, a is negative, okay. Now let us consider that a is if a may be real or some complex number. So if a is complex, then we can write in terms of r into e to the power j theta, okay. So if a to the power n, then it is r to the power n. Then also overall it is j e to the power j theta n, so it is cos theta n plus j sin theta n. So it is actually represented as the real part and imaginary part. So real part is r to the power n cos theta n, and imaginary part is r to the power n sin theta n. So both are oscillatory, okay, because cos and sine functions are there. It is changing. Now their amplitude, what is the amplitude? So amplitude is this r to the power n, okay, r to the power n. And what is the phase angle? Phase angle is the theta part, phi e to the power j theta n. So it is theta n is the, because this one tan inverse of real part, imaginary part by real part. Imaginary part is sin theta n and real part is cos theta n. So tan inverse of tan theta n is actually theta n. Okay. So theta n is your phase angle. So it is, now you see it is a straight line, equation of straight line, theta n. So what is the plot? So for this signal, if it is 0.9, say let us take that r is equal to 0.9, okay, so it is less than 1, so its value should, if the envelope is like this, decreasing function, decaying function, it is like that, and its graph phase angle plot is somewhat like this, okay, this is the phase angle plot. So because theta n, if theta, and let us consider that it is theta is equal to pi by 10. Okay, pi by 10. So it is phi n is equal to pi by 10 into n. So but we consider theta to be within minus pi to plus pi. Okay, because this value is actually plotted. It is actually after this. It is after this. It is repeating. Okay, it is repeating. So it is this kind of straight line. Okay, for this phase function. It is a modulo 2 pi phase angle. So it is repeating after this sample. Now, okay, so these are the basics properties of signals. We have seen that some elementary signals and some functions. Okay, so now we go for certain classification of signals. Okay. So first classification is energies. I am not going into the mathematics of it. Just I will go and ask you some questions because you have seen many times while studying many courses. Okay, that what do you mean by energy signals and power signals? Okay, can anybody please tell what do you mean by energy signals and what do you mean by power signals?
Sir, energy signals have finite energy and they are non-periodic, and for power signals the energy is infinite and they may be or may not be the periodic signals.
Yes. So now my another question is that how do you define the energy of a signal mathematically? Or power means what? Power of a signal. Anybody else?
Sir, the integration of amplitude squared into the differential time will give us the energy, and if we divide it by average time, we get the power.
Yes. So so any signals that a square magnitude square, say it is voltage into current or voltage. So V into I is the power. So I is equal to V by R. So it is V square by R. So whatever it is, magnitude gets squared. So now this is the power. So if you take the sum of the all powers over certain range, over infinite range, so sum of power is actually the energy. Okay. So sum of power, so power consumed over certain time is called energy consumed. So energy dissipation. So that's why integration is taken, and integration is taken in case of the continuous signal. And in case of discrete signal, what is taken in the equation?
Sigma.
In case of discrete signal, the summation or sigma is taken. Okay, so summation of xn square. Xn is your signal and its square is the magnitude, means magnitude square of the magnitude will give you the power, sum of the power. So that means sum of power is energy. So whenever these values, so this is given, you can see in the slide that energy is sum of the magnitude square minus infinity infinity. Now, if you divide if you divide it to time, okay, time, say it is sequence, one sequence is there, a range of time sequence is there, minus n to plus n. Okay, so whole sequence is now 2n plus 1. Okay, So the signal, if we take one period only, okay, one period, say it is from minus infinity to infinity, okay, then this thing, the power is actually divided by this. Now, divided by this energy divided by power. So this way you can calculate the energy and power. Now, question is, energy is signal means the energy is finite, okay? And power signal means average power is finite, okay? Then we'll call the signal to be power signal when the average power is finite, and when energy is finite, then we call it the energy signal, okay? And say for periodic signal, it is seen that periodic signal is generally a power signal, okay? That you see that we are not you just go through the mathematics, that you will see that P is finite, the signal is called the power signal, okay? So we are not going through it now. One example, let us take one example of the signal, that is unit step signal, and determine whether it is power signal or energy signal. So we take the unit step sequence, okay? Unit step sequence is UN, and since it is U square n, magnitude square, so it range is, and unit step range from n is equal to n greater than equal to 0, okay? And say let us take one certain duration, it is 0 to n. So because it is only positive side signal, so it is 0 to n U square n. So according to the formula, it is 1 by 2n plus n into, and according to the series of this, okay, it gets n plus 1. So n plus 1 divided by 2n plus 1, okay, it becomes half. So power is half. It is actually a DC signal, okay? Unit step function is actually a DC signal. So obviously its magnitude is 1, okay, throughout the time. It's for unit step, so its power is half, okay, average power is half. So that's why it is power signal, okay? Now one exercise is given to you, that prove the unit ramp sequence is neither a power signal nor an energy signal, and you should this do yourself and post on the chat box, okay? You should do it yourself, not now, the day before, the time before our next class. You should, tomorrow is your next no tomorrow is the next class, so before that you should submit to the chat box that prove ramp signal is neither a power nor a energy signal, okay? Now going to the next classification, that periodic and non-periodic signal. These are all known to you, okay? Generally, x of n plus n is equal to xn. Then n is called periodicity of the signal, okay? And and also we have discussed that periodic signals are power signal. This is the proof. Now, even and odd signal we have already studied earlier in earlier classes. You have seen even and odd signal. Now we are not discussing here. So now some manipulation of discrete time signals. So here you must be responsive while discussing this. So time signal, time shift. What do you mean by time shift? Now let us say xn is this kind of signal you are given. Okay. Initially it is a ramp kind, and then it's a pulse type, rectangular pulse type. So initially it is increasing, after that it is remaining constant. This is one kind of signal. This is x of n. Now, if you provide some delay to this signal, what do you mean by delay? delay means the signal will appear after some time. Okay, whatever the signal is there, it will appear some time. So x of n is your signal. Now if we make it x of n minus k, x of n minus k. Okay, so if k is positive, that means it is a delay. Okay, and if k is negative, that means it is an advancement. So in that case, it will become n plus k. Okay, so let us take n minus 3. K is equal to 3 plus 3. K is equal to 3 plus 3. So it is x of n minus 3. So it is delay by 3 units. Okay, and that means right shift of the signal. So that means if you put n is equal to 3 over this variable n minus 3, so it becomes x of 0. That means it will, this is the value that has originally will come, the value at n is, if you put n is equal to 3, that means it becomes x of 0. So x of 0 of what? X of 0 of the original signal. So the value at x of n at n is equal to 3, the value at n is equal to 3, okay, of the shifted signal, value of the shifted signal at n is equal to 3 is actually equal to the value of the original signal at n is equal to 0. Okay, n is equal to 0 में 4 था, n is equal to 0 में अब वो अभी n is equal to 3 में आ गया. ठीक है, ये है राइट शिफ्ट और डिले. सिमिलरली एडवांसमेंट में x ऑफ n प्लस 2, ये लेफ्ट शिफ्ट होगा. लेफ्ट शिफ्ट मतलब यहाँ पे लेफ्ट शिफ्ट कैसे करोगे? n इज इक्वल टू प्लस 2 है, n इज इक्वल टू माइनस 2 में जो अगर पुट करोगे, इफ यू पुट n इज इक्वल टू माइनस 2, दैट टाइम इट बिकम्स x इक्वल टू 0. मतलब ओरिजिनल सिग्नल में x इक्वल टू 0 पे जो वैल्यू था, ओरिजिनल सिग्नल में x इक्वल टू 0 पे जो वैल्यू था, वो अभी n इज इक्वल टू माइनस 2 पे आएगा. ठीक है, तो x ये वैल्यू 4 था, यहाँ पे n इज इक्वल टू माइनस 2 में, n इज इक्वल टू माइनस 2 में वैल्यू है ये वैल्यू, और वो एक्चुअली n इज इक्वल टू 0 में था ओरिजिनल सिग्नल में. ठीक है, ये तो म्यूट हो जाता है, ये कहाँ रहता है? nn, ये nn कहाँ है? निश्चय तुम अपना फोन, ये मोबाइल या लैपटॉप जो भी है उसको ठीक करो, बार बार ऑन हो जाता है. अच्छा अभी देखो, अभी ये हो गया. नेक्स्ट, हाँ, ये डिले और एडवांसमेंट. नाउ टाइम अभी वो बताएंगे हम कि टाइम रिवर्स. so n is minus 3 means at delay and n plus 2 it is advancement, left shift. Similarly, time reversal is what? Time reversal just anchors the signal at n is equal to 0 and flips it. Okay, and flips at n is so मतलब दोनों साइड रिवर्स हो जाएगा. जो पॉजिटिव एन में था वो नेगेटिव एन में आएगा, जो नेगेटिव एन में था वो पॉजिटिव एन में आएगा. ये जस्ट टाइम रिवर्सल है. नाउ अब सिंपली यहाँ पे हम लिख के रखें. सो नो प्लस एन के लिए जो शिफ्ट है, n माइनस के मीन्स डिले एंड n प्लस के मीन्स एडवांसमेंट, लेफ्ट शिफ्ट. एंड माइनस n के में जस्ट ऑपोजिट है, n माइनस n माइनस के में इट इज एडवांसमेंट, okay, by k, and minus n plus k में it is delay. Now एक एग्जाम्पल देके इसको सॉल्व कर सकते हो कि x माइनस n प्लस 2 अगर ये है x माइनस एन प्लस टू, उसको प्लॉट कैसे करोगे? x माइनस एन प्लस टू, इसका दो तरीका है. फर्स्ट यू कैन डू शिफ्ट बाई टू, n प्लस टू करो, x ऑफ n प्लस टू करो. Okay, first take the original signal x of n, then you shift left, that is advancement by 2, and then you flip the signal, flip the shifted signal. ये भी कर सकते हो, और नहीं तो पहले ही x माइनस एन कर दो, उसके बाद एडवांसमेंट, उसके बाद डिले कर दो. ठीक है, फर्स्ट फ्लिप देन डिले, दो तरीका है. ठीक है, अब ये सब हम डिस्कस नहीं करेंगे. फिर टाइम स्केलिंग. अच्छा अभी देखो ये यहाँ पे क्या है, टाइम डिले एंड फोल्डिंग. टाइम डिले एंड फोल्डिंग, these two are not cumulative, commutative, because first if you make time delay and then you make fold, this does not mean that first you fold then you time delay. These are same. Okay, it's not that. So here folding means folding of xn, means you get x of minus n, and then you put delay of x of minus n plus k. Delay means in minus negative time reversal case, delay is plus k. Okay, and here first delay then folding, so delay is x of n minus k and folding is x of minus n minus k. So these two are opposite, so these two are not commutative. Then time scaling. What do you mean by time scaling? Time scaling means either it is down sampling. Okay, so let us take one sequence. Okay, this way it is given, long sequence is there. Now we make one sequence out of this. So it is x of 3n. X of n is this, and x of 3n is this one. So means we take the samples. Okay, we take the third samples each time out of the original sequence. So this sequence is taken, this sequence is taken. After that we take the third samples. Okay, after that we take the n is equal to 2. Okay, so when n is equal to 0, it will remain same. At n is equal to 1, we take the x of 3, that is third sample. When n is equal to 2, we take the 3 into 2, that is 6 sample. Similarly, so this way we can see the samples is reducing. Okay, number of samples is reducing, so it is called down sample. This is graphically represented here. Okay, now we have some input output description of systems. Okay, so delay unit delay system. Let us take one signal xn, it is delayed by 1 in it. This is graphically represented here. Okay, now if you want to take some average of the previous previous three samples, so xn, then xn minus 1, okay, then xn minus 2. Okay, so this is the previous samples. Okay, so here don't confuse with the delay or shift of the part. It is actually representing the, it is not delaying, it is actually a delay, but it is a previous sample. Okay, in this way you can imagine that when n is equal to 2, that means actually we take this, will actually it is at n is equal to 2, we get the previous samples. Okay, x of 1. Okay, here x of 1, n is equal, let us say n is equal to 2, so y is equal y of 2, so it is x of 1. That means the sample of the previous sample of x, okay, is considered as the present sample of y. So that means actually it is also one kind of delaying, and it is also coming in the sense that it is the sequence or signal will come in future. The delay means future. जो value 1 second में आ रहा था, let us say x of 1 let us say first sample में आ रहा था, वो अभी second sample में आएगा. इस तरह से सोच सकते हैं. So now in this case moving average filter x of n plus or, so it just takes the average, okay, of the first 3 samples and then calculate the average and make the present samples, value of present samples. Accumulator accumulates all the previous values. That means they add all the previous values. This is called accumulator. Okay. Now here, so these are the all some examples of input-output relations. So here one example we can see that yn is equal to y of n minus 1 plus xn. Okay. So we can mean that rewrite. We can also rewrite the this sample of accumulator that all the previous values are taken. So previous values is what? Yn and yn minus 1. So say it is already one system is there, okay, that gives some feedback to the input with some delay. So output is feedback, output is yn, okay, it is delayed and it becomes yn minus 1 and then it is added with xn, the present sample. So each time it is getting added. Each time it is getting added, so it is actually accumulator. So it will so these are up to this I just wanted to explain now what is the time. Okay. So now anybody has any question from the discussed topics? Do you have any question?
No, sir.
सब समझ में आ गया?
Yes, sir.
अच्छा, वेरी गुड. अजय एक चीज बताओ, जब समझ में आ गया. How the sampling frequency should be, how we get the relation between formula for sampling frequency. What is the relation? How do we get it?
So the sampling frequency should be greater than or equal to 2 into bandwidth. So it will cover both the low pass signal and band pass signal.
From the discussions of the discrete time frequency, how we get. Anybody else can respond? Nishchay, tum batao. Discrete, what is the range of discrete frequency? Harshvardhan?
Sir, I don't know, sir. I joined little bit late, sir. जहाँ से सुना उतना समझ में आया, sir. Power cut के से late join किया.
The discrete frequency range. Anybody? I repeated also at the beginning.
minus 0.5 to 0.5.
Yes, minus 0.5 to plus 0.5. So from that you can easily get the relation of the sampling frequency. Okay. So have you gone through? Have you seen that explanation in the slides I have given?
Can you upload the slides?
Yes, who is telling? Who told just now? Sure. Okay, I will just upload these slides. Okay, and by tomorrow, okay, you should be prepared all the things that I told till now. Okay.
Yes, sir.
Okay, fine. Now you can leave.
Thank you, sir.